Okay, this is my second try through this situation. Hopefully the sound works. I just tested it and it seemed to, so here we go again. So this in the notes package is solving quadratic equations. So we're going to be looking at how we solve them algebraically. The last section was solving graphically, and remember that you always have that in your back pocket. So there was the two methods for solving. There was solving method one, so setting y1 equal to 0, and then looking for your zeros or your x-intercepts or your roots of that particular equation. And then method two, I don't necessarily use as much, where you put your left side of your equation into y1 and your right side of your equation into y2 and trace the points of intersection for that. So both of those are always an option, but if I ask you to do something algebraically, you're going to either do it by factoring if possible, or by doing the quadratic formula. So this is actually two separate sections. I'm going to record it all as one lesson, but we'll consider it two separate sections. So it says from yesterday, which is obviously not true. Oh, let me full screen so I can write. So from yesterday, we've been looking at quadratic functions, but again, we're looking at the quadratic equation where we have it equal to something. So we're required to find all possible solutions, also known as roots, for the independent variable. That's usually x. So a definition that's important: the roots of an equation are all values of the variable that make the equation true. That is, when substituted into the equation, the left side of the equation is equal to the right side of the equation. The roots are also known as the solutions to the equation. So if we have an equation, we can try to solve by factoring. It is important to set, oh my goodness. Sorry, this thing is a little finicky. The equation equal to 0. So that's important for factoring. We need to set it equal to 0 in order to solve. So we could, in theory, sit and guess values for x here. So I could say maybe x is equal to 1. Well, 1 squared, subtract 9 times 1, subtract 52. That would not be equal to 0. So that one doesn't work. And we could sit and plug and chug these in, and it's not going to get us anywhere particularly fast. So again, these algebraic methods will get you there a lot faster. So this first one, again, a key part is making sure that it's set equal to 0, which it is, so that is a good thing. So now what we want to do is we want to see if we can factor it. So we want to factor, again, you could do this by decomposition, or by inspection, or your happy little box method that Corey has done with you guys. That can definitely work for this. Sorry, I'm using this tablet and I don't have enough room, so I'm just going to shift stuff around in my house. That hopefully hasn't messed up anything. So factoring by decomposition or by inspection. So I'm going to do by inspection, since my number in front of my x squared, we'll call that our a value, is currently equal to 1. If you want to look back, remember that review package from the beginning of the year, we did a whole bunch of factoring stuff. So by inspection, we're looking for two numbers that multiply to be equal to my c value, which is negative 52, and add, sorry, this is finicky, add to be equal to negative 9. So we know if they multiply to a negative number here, so since it multiplies to negative 52, we know we need to have a positive and a negative. And since it adds to a negative number, we know that our negative one needs to be bigger. So you could write out all of your factors of 52. So 1 and 52, 2 and 26, 3 might work. I know 3 doesn't work, but 4 works. So 4 and 13, 5 doesn't work. 6 doesn't work, whatever. You could write out all of your factors of 52. I'm just going to keep going. Um, so our factors are 13 and 4. We know, again, the bigger number needs to be negative since it adds to negative 9. So negative 13, positive 4. So what that gives us is we just put it in. So x minus 13 times x plus 4. And again, this is all equal to 0. So we factored that trinomial part. We factored this portion as a product of x minus 13 times x plus 4. You could FOIL that out and you would get back to that original equation that we have up there. So now what we want to analyze is what makes each of these factors equal to 0. So if we look just one by one, so x minus 13, what makes that equal to 0? And x plus 4, what makes that equal to 0? Because if either of these two factors are equal to 0, the whole equation will be equal to 0. So now I want to solve for x from here. So x, if I added 13 to both sides, that would get me x equals 13. And on this side, if I subtracted 4 from both sides of the equation, we would get x is equal to negative 4. So what that is the roots of our equation, or what should make our equation true. So what should make our equation true from our original equation? So from here, we would want to, oh, sorry, I'm off the page. We would want to verify each separately by substitution. Oh, I've spelled this substitution or graphing. Sorry, that's looking crazy messy. So it says verify each separately by substitution or graphing. So I'm going to do it by substitution because I don't have a calculator sitting in front of me. So you need to do them each separately. So we'll do the first one, x is equal to 13. So now what we're going to do is substitute it into our original equation of x squared minus 9x minus 52 is equal to 0. So I'm going to substitute in anywhere there's an x, I'm going to put in a 13. So 13 squared minus 9 times 13 minus 52. So 13 squared is 169. 9 times 13 is 117. So negative 117 minus 52. So 169 subtract 117 is 52. 52 subtract 52. So since my left side of my equation equals my right side, we know that 13 is a valid solution. So now we can try substituting in negative 4 for x. So we have to do these separately. It's not like you can plug them in both at once. Sorry, I don't know how to erase, so I'm just going to scribble that out. 9 times negative 4. So negative 4 squared, negative 4 times itself is 16. Negative 9 times negative 4 is going to be plus 36 and minus 52. So 16 plus 36 is 52. 52 minus 52, 0 equals 0. Sorry, I was kind of mumbling there. I said 0 equals 0. So since my left side, oops, sorry, this thing is quite the pain. So since our left side is equal to our right side in both of these cases, we are happy, and that is a valid solution. And so that would have taken a little while to plug and chug it in to find both solutions of positive 13, negative 4. So factoring it is a much better approach. On to our next question. Just gonna scroll myself and make my page longer in case. So our next question here, if I can move my recorder to the other corner. So now we have Again, we have a quadratic, but right now it's not equal to 0. So what I need to do is set it equal to 0. So to make that happen, I need to subtract 8 from both sides of the equation. So now I'll have 9x squared plus 21x minus 8 is equal to 0. So now we have a quadratic in our standard form set equal to 0. And we are happy with that. So we're going to factor this by decomposition. So again, if you want to do it by your box method, give that a try. Maybe pause the video and make sure that you get to the same value as me. But again, we want to write it as a product of two binomials, so we want to factor that out. But for factoring by decomposition, we need to find a number that multiplies to whatever a times c is. So my a is 9, my c is negative 8. So we're looking for two numbers that multiply to be equal to negative 72. And we're looking for them to add to b. And so again, our b is 21. So again, you'd write out all of your factors of 72 and figure out which pair will satisfy this. We know one needs to be a negative and one needs to be a positive, since they multiply to be equal to a negative. And our positive needs to be the bigger value, since they add to a positive number. So this is actually negative 3, positive 24 are two values for this. They multiply to be equal to negative 72, and they add to be equal to positive 21. So what these numbers are getting us is they're actually splitting our b term into two parts. So our equation, when we had it written out there, so 9x squared plus 21x minus 8 is equal to 0. What we've done with these terms is we've split our b term. So 9x squared plus 24x minus 3x minus 8. So what we've done is we've split this term into two parts. Sorry. And now what we're going to do from here is we're going to factor these two portions independently. So you're going to kind of ignore what's happening in the second half here and looking at these two terms, what we can factor out. So I know that I can factor out a 3 of both 9 and 24, and I can factor an x out of both as well. So if I'm dividing by 3x, I'm going to be left with 3x plus 8. Because again, 24x divided by 3x is 8. The second two terms, so negative 3x minus 8, not a whole heck of a lot you can factor out, but I'm going to factor out a negative 1. So I can't take an x term because there's no x term here, and there's no common factors in terms of the number. So if I'm factoring a negative 1 out, this is going to become positive 3x. And if I'm factoring a negative out, this is going to become positive 8. So once I've done that, you can see that we have the same factors in both parts here. So I'm going to remove that factor of 3x plus 8. And our other factor will be whatever is left over. So this portion and this portion. 3x minus 1. And again, that's all equal to 0. So now we've written it factored out, which is good. Still not quite right though, because we haven't got a value for x that makes it true. So again, what we need to do is analyze what makes each of these equal to 0. So 3x plus 8, what makes that factor equal to 0, and 3x minus 1, what makes that factor equal to 0. So again, now from here we're solving for x, so we're looking to isolate x, get x by itself. So I'm going to subtract 8 from both of those. On the second factor, I'm going to add 1 to both sides of the equation, so 3x is equal to negative 8. And in this case, 3x is equal to 1. If I'm still trying to isolate, get x by itself here, I'm going to divide both sides of the equation by 3. Same thing here, since it's 3x, I'm going to divide both sides of the equation by 3. So our values are x equals negative 8 over 3, and x is equal to positive 1/3. So those are our values for x. Ooh, that should, oh my gosh, going crazy with this tablet. Should make it true. And so again, you'd want to verify by substitution or graphically. This one might be easier to do graphically just since we've got fractions, but it's really not a problem to verify by substitution where you would substitute in each of those separately to make sure that our left side of our equation is equal to our right side of our equation. I'm just going to do one of them. You can do the other if you want. So our original equation, I want to go with what we had at the beginning. So 9x squared plus 21x is equal to 8. I'm going to substitute in, I'll substitute in the second one. So 9 times 1/3 squared is equal, is equal to plus 21 times 1/3 is equal to 8. So 1/3 squared is actually 1/9 plus 21 times 1/3 is equal to 8. And so 9 times 1/9 is 1. 21 times 1/3 is 7. 1 plus 7 is 8. 8 equals 8. We are happy. You can try substituting that other one, but I think that's already enough for me. So that's the first part of solving algebraically. So you might want to just pause the video here and try some of the factoring practice questions. Practicing your factoring, that's the big thing. So at the bottom of the page it says, hint, always substitute your answers into the original equation to verify. You can also solve graphically to check your answer. However, solving by factoring may not always be possible, may not always be a possibility for quadratics. So this is the second method of solving algebraically, and this is using the quadratic formula. So if you can always use the quadratic formula, even if it can be factored, you can do it. But this also helps if it's not something that's easily factorable. So I'll talk about that in a bit. I'm just going to make sure I didn't turn my headset off. Hang on. No, it looks good. So our second method, so if the quadratic is in the form ax squared plus bx plus c is equal to 0, so again, standard form set equal to 0, the roots and solutions can be determined using the quadratic formula from your data sheet. So you do not need to memorize this. Don't worry about that, but you do need to know how to apply it. So the quadratic formula will always give you an answer for x. Since it says and, I assume it's answer, but it could be solution is probably a better way to say it. So if asked for an exact value, do not round a decimal, but instead leave your answer as a radical. So in one of the questions, we'll see this happen. Usually you guys like to give me a decimal value, but if it's asking you for an exact value, leave it as a radical, even if it looks pretty funky. So this first example problem, this is the same as we had for factoring, so we should get to the same answer. So this was our last example that was able to be factored. So what we see is it's in standard form and set equal to 0. So looking at that, what we want to figure out. So again, standard form ax squared plus bx plus c equal to 0. 0. Oh, I'm off the edge, that's why. 0. This is a b. So looking at that, our a value right now, so our number in front of our x squared is a 1. Our b value is equal to -9, and our c value is equal to -52. So what we need to do for this one is just substitute in to that quadratic formula, this big beastie guy, a, b, and c. So I'm just going to write it out because I have it, or I had to scroll it off. So x is equal to -b that symbol that I'm writing right here. So that's saying plus or minus, and we'll see what that exactly means as we go. But keep that straight, that this is saying plus and subtract. We'll need that in a bit. Square root of b squared minus 4ac. All of that is under our radical symbol. All of it is the radicand, divided by 2 multiplied by a. So now substituting in the values that we have up here. So -9. I'm going to write out all the steps. If you think you're a calculator wizard, all the power to you. I personally, I am a bit of a calculator wizard, and I still break down these steps because it's very, very easy to make a mistake with brackets or not put something in quite right. So you'll see that I write down all of my steps before I actually start calculating it. So 2 times a is 2 times 1. So now I'm going to clean it up a little bit. So if I have subtract -9, we know that's going to be +9, plus or minus, oops, that went way downhill. So -9 squared, -9 times itself is 81. -4 times 1 times 52 is actually positive 208. So again, this is negative times a positive times a negative, so it's going to be positive 208. And 2 times 1 is 2. Let's clean it up still a little bit further. 9 plus or minus the square root of, so 81 plus 208 is 289 divided by 2. And we actually know if you punch square root of 289 into your calculator, you might not have recognized that, but it is a perfect square. So the square root of 289 is 17. So 9 plus or minus, oh, so now I gotta do this. Eraser. Oh no, that's okay. I'll sort it out. I made a mistake there. It's not plus or minus the square root of 17. So it's plus or minus 17, because again, the square root of 289 is 17. So we want to look at these two situations that come from this middle part. So we want to look at 9 plus 17 divided by 2. We want to look at 9 minus 17 divided by 2. So these are our two situations that we need. So 9 plus 17 is equal to 26. 26 divided by 2 is 13. So that's our x equals 13. 9 subtract 17 is -8. -8 divided by 2 is -4. So what you'll see is those were the two solutions that we had before. So x is equal to 13 and x is equal to -4. And so again, when you get to that, you would want to verify it. We already did the verification on the last page, but again, make sure you're verifying either by substitution or graphically. So looking graphically at tracing your roots. So that's the quadratic equation. Let's do another one. So again, we are happy we have it in standard form. Set equal to 0. So looking at our a, b, and c values, so our a value is 4, our b value is -7, and our c value is equal to -3. So substituting into the quadratic equation, so x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. So substituting in our values, so -7, so I've substituted in for a, b, and c. So negative 7 squared is positive 49. Negative 4 times 4 times negative 3, it is positive 48. Yep, that should be an 8, not a 6. So again, simplifying, yeah, trying to punch it in your calculator, you're going to get some funky answers, and we'll talk about why. So 49 plus 48 is 97 divided by 8. So 97 is not a nice perfect square. Um, we can't square root it. It's somewhere between 9 and 10, but it's not easy to figure. So we're going to look at our two situations. So we're going to look at 7 plus the square root of 97 divided by 8, and 7 subtract the square root of 97 divided by 8. And so at this point, these are actually our exact values. So if I was asking you an exact value, even though it seems kind of wild to write that as an answer, it is actually correct because we don't want to get a rounded value associated with this radical. If you wanted a rounded answer, you could punch it in your calculator and get your decimal approximation. So this first one, I believe, is 2.106. There might be more numbers after that. And this second one is negative 0.356, and there's probably numbers after that as well. So this is your rounded answer. Again, keeping more decimals is not a bad idea. You would want to still verify. It keeps looking funny. I don't know why. I keep moving it too much. Verify by substitution or graphically. Substitution, best case is you're putting in these exact values. It's probably a little bit easier to use your rounded values to put in, but you need to keep lots of decimal places. Otherwise, you'll end up with your left side not being equal to your right side. If it's off by a little bit, like if I don't have a calculator with me, so I can't really do it right now, but try substituting in x is equal to 2.106 into the original equation. I'm just gonna quickly do that on my phone. Sorry. So 2.106 times 2.106 times 4, subtract, I need brackets, 7 times 2.106, close brackets, subtract 3. So what that gets me when I put it into the calculator on my phone really quickly is negative 0.001056. It doesn't really look like it, but this is essentially 0. The reason that it's not our 0 equals 0 is because this is a decimal approximation. Again, I rounded it. If I kept more decimals, it would probably be even closer to 0, but this is essentially right. It might be, for some of these ones, easier to do it graphically and just compare if, when you trace the zeros, if that number is the same value. But verifying by substitution still works here. You just have to be pretty cognizant of if it's not quite 0, that just came from this. If we got something like 6.4 is equal to 0, no, that's definitely not true. This is pretty close, so we could use that, but if you get a number that's way off, you definitely don't want that. I'll do one more. We'll leave that word problem that's actually at the end, and we'll save that for our lesson for next week. So one more. So quadratic, because again, we have that x squared. Right now, it's not in standard form, so we want to put it in standard form. So that would be 5.1x squared minus 2.7x. I'd add 3 to both sides of the equation to set it equal to 0. Sorry, I'm scared I might sneeze if it gets really loud. No, it disappeared. So A is equal to 5.1, B is equal to negative 2.7, and C is equal to 3. So substituting into our quadratic formula. Again, you don't need to memorize it. Uh, but you're going to write it a lot the first couple of times that you might actually start to memorize it. So substituting in our values for A, B, and C. I guess A, we know the value of. A is 5.1. Sorry, just ignore that. So starting to clean up, so if I'm subtracting a negative, so 2.7 plus or minus the square root of 2.7 squared, negative 2.7 squared, I guess, is 7.29. Subtract, so 4 times 5.1 times 3 gets me 61.2. Again, negative, positive, positive, divided by, so 2 times 5.1 is 10.2. Ah! I promise I'll get good at this tablet by the time we're done learning online. 61.2. Oh, why am I rewriting the same thing? Blah, 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 blah. 2.7 plus or minus square root of, so 7.29 subtract 61.2 gets me negative 53.91. These are getting annoying, but I don't think I can click it with the pen. So 10.2. So what you hopefully, since you are such a pro at radicals, hopefully what you recognize right now is under that radical symbol. Oh, come back, come back. Under that radical symbol right now, we have a real problem. So we can't have a negative radicand. So we can't have a negative number under a square root symbol. There's no number that multiplies by itself to give a negative. So we can't have a negative radicand. So there are actually no solutions. The graph does not actually cross the x-axis. So if you punched it into your calculator and tried to graph it out, it looks something like this. So there are no values for x that make it true. So that one, there's just actually no solution. So if we look back, there's no way to put a value in for x that would make your equation true. So that's something that you can come across. So that is that. You've got some questions in your textbook for both solving algebraically by factoring and solving algebraically by the quadratic formula. So you need to do some practice with that. Next week, I will get you a lesson on some of the word problems that you can come across with quadratics. So stay tuned for that. All right. Hopefully the sound worked. Talk to you later.